Hi students, welcome to our physics class. In this class, I am going to explain the topic law of flotation. To learn the law of flotation, we must know about the relative density. What is relative density? Relative density is equal to, the definition of the relative density is the density of the substance compared with the density of the water. Here we can write formula. Relative density is equal to, from the definition we can write formula, density of the object by density of the equal volume of water. So here density of the object by density of the water which is equal volume to the object. So both must have same volume. That is the formula. Now here from this formula we also can write relative density is equal to weight of the object by weight of the equal volume of water. Now to find this, how to find? We will find out the weight of the object and also find the weight of the equal volume of water to the object. The object and water must have equal volume. So object weight. How to find the object weight? You know, by using any simple balance or digital balance, by any balance, spring balance, by any balance we can find the weight of the object. That is simple method. Now how to find the equal volume of water to the object? So the water must have equal volume to the object and find the weight of the water. Weight of the water which is equal volume, which is having equal volume to the object. How to find? So there is a method. See, this is Eureka can. By using Eureka can, we can measure the equal volume of water. See how to find out what equal volume of water. Take an object and drop in the water. So when we drop the water, then water level rises. Water level rises and goes through this nozzle. So take some water in the Eureka can up to nozzle and drop the object in the Eureka can. Then what will happen? The water level rises and overflows through the nozzle into another beaker. So this water what we collected in another beaker, this volume of water is equal to volume of the object. So such a way we can find out the equal volume of water to the object. So now we can say volume of the water is equal to volume of the object. Both volumes are same. Now we can find out weights. Weight of the object we can find by using simple balance or any balance. Weight of the water also we can find out by using some methods. Empty jar measure and take this liquid and find again the weight of the jar with liquid and subtract this weight minus previous weight, then you will get only liquid weight. So in previous class we discussed about how to measure the weight of the liquid. So find the weight of the liquid, this overflow liquid and weight of the object. These weights, by using these weights we can say law of flotation. Now see, when weight of the object, if you take weight of the object as W and weight of the water, what we collected here, equal volume of water, the weight of the water we take as FB, the simple FB. What is the meaning of FB? This is beyond force. FB means what? Beyond force. The beyond force is equal to weight of the water. What is the beyond force? Beyond force means a force acting upwards by the water. A force acting upwards by the liquid. Here weight of the object always towards the downwards. Weight of the object is always towards the downwards. Weight of the water equal to beyond force. What is meaning of beyond force? A force act on the body against to the gravity, opposite to the gravity, the opposite to the upward force, that is called upward force is called beyond force. That is equal to weight of the water. Now weight of the water is equal to beyond force, taken as symbol FB. Now weight of the object is W. Now we can compare if the weight of the object in previous class only we discussed this. Weight of the object is equal to beyond force. Then what will happen? The object sink and float under the surface of the water. Sink, the object sink under the surface of the water and sink and float. Sink and float, not completely sink, just under the surface it sink and float. So here weight of the object equal to weight of the water, equal volume of water, or we can say weight of the beyond, also we can say beyond force. This is also weight of the water, also we can say beyond force, upward force. So both are equal, object weight and upward force equal, then what will happen? Object will not completely sink, just it will sink and just sink under the surface and float. So this is called law of flotation. When, what is the law of flotation? When object weight equal to weight of beyond force, object weight is equal to beyond force, then object sink and float. The object immersed object sink and float. So now this is the law of flotation. Now some applications of flotation in our daily life. What are the applications of flotation? See, some applications we can see by using these some applications we can see here. Iron ship floats. You know, iron nail sink in the water. Iron nail sink in the water because the weight of the iron nail and water volume or weight of the water which is equal volume to iron nail is compared. So then iron nail weight is more than the water volume, equal volume of water weight. So water weight is less than the iron nail. So that is why force is overcomes. Force, what is that? Weight is overcomes. Weight, which weight? Object weight, nail weight is overcomes than the water weight. So then that is why the nail sink into water. But the same ship is made with iron, huge quantity of iron. Small iron nail sink, but the same ship is made with huge quantity of iron, but not sink. What is the reason for that? So there is a reason. See, that is depends on shape of the object. Here, the boat or ship made by iron and shape is wide. The shape is wide. Then when it is sink in the water, when it is moving in the water, what will happen? That water displaced from that place. When it is moving in the water, wherever that boat is there, where it presents, at that place water displaced. That displaced water weight is more than the ship weight. Why? Here range is more, the area is more, under that occupied that area is more. The ship will sink some depth or little length, up to some depth it will sink. So because of that ship water displaced, the displaced water weight is greater than the ship. And other way we can say the weight of the ship, the density of the ship is less than density of the displaced water. Density of the ship is less than density of the displaced water. Why? Here the ship is inside the ship empty, only sheet is folded, bottom sheet is folded, inside the ship is empty, but occupying water weight is more, water density also more than the ship. So that is why the ship will not sink. Next one, see, swimmer can swim easily in the sea water than the river water. Why? Here sea water is more denser than the river water because sea water consists salts. Some salts are consist in the sea water. So because of that, sea water is more denser than the river water. So because of heavy density, the upward force act on the swimmer. So that is why he can swim easily in the sea water than the river water. So that is also we can apply for this rotation. Rotation is applied for this swimmer. Next another application is ice floats on water. You know, when you drop an ice cube, it floats above the water. Though it is solid, ice is solid, water is a liquid, but it floats above the water. Reason, the densities are different. Here, particles, the attraction force between particles, space is more, attraction force is less, space is more in ice, but water particles are some closer than ice. So that means your density of the water is more than the density of the ice. That is why, so that ice can float. Density of the water is more, because of that density of the ice is less, because of that the ice will float above the water. Beyond force act on the ice, that is the reason ice floats above the water. Next one, submarine. You know, submarine have chambers, empty chambers. In the submarine structure, there are some empty rooms in the submarine. That empty rooms are filled with water. Then what will happen? That submarine will sink in the water and float, sink and float. But if the empty chambers are, water is removed from the empty chambers, what will happen? When water is removed, that is filled by air. So then what will happen? Density changes, density decreases. The submarine density decreases than the water density. Then immediately what will happen? The submarine float above the water. So that is the reason submarine can float above the water and sink and float inside the water. When it is, tanks are filled with water, it sink and float. When it is removed water, the density decreases and float above the water and travel. So that is the reason submarine can swim, submarine can float inside the water and above the water. Next, whales. Whales, you know, the aquatic animal, whale. So in that inner organs, bladders are present in that whales, that air bladders. Those air bladders are filled by air. Whenever it is filled by air, immediately the density decreases. Density of air is less than the density of water. So that is why density of the whale decreases. It rises up. It rises up because of beyond force. Water force is more density causes more beyond force, upward force, and that is why the whale can float above the water. Whenever it comes above the water, it comes by filling the air. If it want, the whale want to sink in the water and float, going to water, then what will do? If it want to go into water, it will remove the air. It will remove the air from the bladder and release the air from the bladder. And what will happen? Then immediately density changes. Density of the ship, the density of the whale increases, and that is why it will sink and float. So see next one, submarine and whale. Next, another example is advertising balloons. We can see in the streets, hanging in the upstairs, and tying at the upstairs. We can see flying at the upstairs. Advertisement balloons. So what is the gas filled in the advertisement balloons? Hydrogen gas. Why hydrogen is filled? Here hydrogen gas is weightless than the weight of the air. Less weight than the weight of the air. And also we can say hydrogen gas density is less than our atmosphere air. So then what will, whenever it is less weight, it floats above the air. The hydrogen flows above the, try to flow above the air in the atmosphere. So that is why it always fly. So if we don't tie, it will go on fly above the atmosphere. But we are taking support by tying that balloons to the support. We are stopping there. That is why it always flies above the air. With the support of any rope. So this is the reason we can say that some objects floats and some objects can sink, and some objects float and sink. By using this relative density, we can express that. That's all for now. Thank you.